Top links presenting AI and the world around us. Thanking you for choosing this video. Please give us a like, leave a comment down below, and please subscribe to this channel for the complete series on this topic. Thank you. Artificial intelligence, AI, is intelligence, perceiving, synthesizing, and inferring information, demonstrated by machines, as opposed to intelligence displayed by non-human animals or by humans. Example tasks in which this is done include speech recognition, computer vision, translation between natural languages, as well as other mappings of inputs. AI applications include advanced web search engines, for example, Google Search, recommendation systems, used by YouTube, Amazon, and Netflix, understanding human speech, such as Siri and Alexa, self-driving cars, for example, Waymo, generative or creative tools, ChatGPT and AI art, automated decision-making, and competing at the highest level in strategic game systems, such as chess and Go. As machines become increasingly capable, tasks considered to require intelligence are often removed from the definition of AI, a phenomenon known as the AI effect. For instance, optical character recognition is frequently excluded from things considered to be AI, having become a routine technology. Artificial intelligence was founded as an academic discipline in 1956, and in the years since it has experienced several waves of optimism, followed by disappointment and the loss of funding, known as an AI winter, followed by new approaches, success, and renewed funding. AI research has tried and discarded many different approaches, including simulating the brain, modeling human problem solving, formal logic, large databases of knowledge, and imitating animal behavior. In the first decades of the 21st century, highly mathematical and statistical machine learning has dominated the field, and this technique has proved highly successful, helping to solve many challenging problems throughout industry and academia. The various subfields of AI research are centered around particular goals and the use of particular tools. The traditional goals of AI research include reasoning, knowledge representation, planning, learning, natural language processing, perception, and the ability to move and manipulate objects. General intelligence, the ability to solve an arbitrary problem, is among the field's long-term goals. To solve these problems, AI researchers have adapted and integrated a wide range of problem-solving techniques, including search and mathematical optimization, formal logic, artificial neural networks, and methods based on statistics, probability, and economics. AI also draws upon computer science, psychology, linguistics, philosophy, and many other fields. The field was founded on the assumption that human intelligence can be so precisely described that a machine can be made to simulate it. This raised philosophical arguments about the mind and the ethical consequences of creating artificial beings endowed with human-like intelligence. These issues have previously been explored by myth, fiction, and philosophy since antiquity. Computer scientists and philosophers have since suggested that AI may become an existential risk to humanity if its rational capacities are not steered towards beneficial goals. The term artificial intelligence has also been criticized for overhyping AI's true technological capabilities. History of artificial intelligence and timeline of artificial intelligence. Silver didrachma from Crete depicting Talos, an ancient mythical automaton with artificial intelligence. Artificial beings with intelligence appeared as storytelling devices in antiquity, and have been common in fiction, as in Mary Shelley's Frankenstein or Karl Čapek's RUR. These characters and their fates raised many of the same issues now discussed in the ethics of artificial intelligence. The study of mechanical or formal reasoning began with philosophers and mathematicians in antiquity. The study of mathematical logic led directly to Alan Turing's theory of computation, which suggested that a machine, by shuffling symbols as simple as 0 and 1, could simulate any conceivable act of mathematical deduction. This insight that digital computers can simulate any process of formal reasoning is known as the Church-Turing thesis. This, along with concurrent discoveries in neurobiology, information theory and cybernetics, led researchers to consider the possibility of building an electronic brain. The first work that is now generally recognized as AI was McCulloch and Pitt's 1943 formal design for Turing-complete artificial neurons. By the 1950s, two visions for how to achieve machine intelligence emerged. One vision, known as symbolic AI or GAFI, was to use computers to create a symbolic representation of the world and systems that could reason about the world. Proponents included Alan Newell, Herbert A. Simon, and Marvin Minsky. Closely associated with this approach was the heuristic search approach, which likened intelligence to a problem of exploring a space of possibilities for answers. The second vision, known as the connectionist approach, sought to achieve intelligence through learning. Proponents of this approach, most prominently Frank Rosenblatt, sought to connect perceptron in ways inspired by connections of neurons. James Monyika and others have compared the two approaches to the mind, symbolic AI, and the brain, connectionist. Monyika argues that symbolic approaches dominated the push for artificial intelligence in this period, due in part to its connection to intellectual traditions of Descartes, Boole, Gottlob Frege, Bertrand Russell, and others. Connectionist approaches based on cybernetics or artificial neural networks were pushed to the background but have gained new prominence in recent decades. The field of AI research was born at a workshop at Dartmouth College in 1956. The attendees became the founders and leaders of AI research. They and their students produced programs that the press described as astonishing. Computers were learning checker strategies, solving word problems in algebra, proving logical theorems and speaking English. G28. By the middle of the 1960s, research in the US was heavily funded by the Department of Defense and laboratories had been established around the world. Researchers in the 1960s and the 1970s were convinced that symbolic approaches would eventually succeed in creating a machine with artificial general intelligence and considered this the goal of their field. Herbert Simon predicted, machines will be capable, within 20 years, of doing any work a man can do. Marvin Minsky agreed, writing, within a generation, the problem of creating artificial intelligence will substantially be solved. They had failed to recognize the difficulty of some of the remaining tasks. Progress slowed, and in 1974, in response to the criticism of Sir James Lighthill and ongoing pressure from the US Congress to fund more productive projects, both the US and British governments cut off exploratory research in AI. The next few years would later be called an AI winter, a period when obtaining funding for AI projects was difficult. In the early 1980s, AI research was revived by the commercial success of expert systems, a form of AI program that simulated the knowledge and analytical skills of human experts. By 1985, the market for AI had reached over $1 billion. At the same time, Japan's fifth-generation computer project inspired the US and British governments to restore funding for academic research. However, beginning with the collapse of the Lisp machine market in 1987, AI once again fell into disrepute, and a second, longer-lasting winter began. Many researchers began to doubt that the symbolic approach would be able to imitate all the processes of human cognition, especially perception, robotics, learning and pattern recognition. A number of researchers began to look into sub-symbolic approaches to specific AI problems. Robotics researchers, such as Rodney Brooks, rejected symbolic AI and focused on the basic engineering problems that would allow robots to move, survive, and learn their environment. Interest in neural networks and connectionism was revived by Geoffrey Hinton, David Rumelhart and others in the middle of the 1980s. Soft computing tools were developed in the 1980s, such as neural networks, fuzzy systems, gray system theory, evolutionary computation and many tools drawn from statistics or mathematical optimization. AI gradually restored its reputation in the late 1990s and early 21st century by finding specific solutions to specific problems. People are the answer to the problems of bits. Top links.